Hello, fellow solvers. This is Cog with Cog Analytics. Today we're taking a look at day 4 for Advent of Code. This is another fairly simple problem with what I believe to be a very elegant solution once you've identified the key insight. Our input is a table of characters, those characters being X, A, M, and S, and the goal of this problem is to identify all occurrences of the target string Xmas, which can occur horizontally, vertically, or diagonally, and can be written both forwards or backwards. The total count of the number of occurrences is our answer to part 1. In part 2, we change things up by instead of looking for that target string, we're now looking for this target pattern, which is the characters MAS, two sets of that in this X-shaped pattern. The order of the M and S is irrelevant to still be considered a match. Again, all such occurrences of that pattern give us the answer to part 2. With that, let's jump into Alteryx, identify the key insight, and take a look at how to solve this problem. Build a workflow. So in Alteryx, we have a string function, namely the regex count matches function, which can be used to identify all matches of a certain string pattern. In this case, our target string Xmas. Now, if we do that on our input data, which comes to us as a single row of text for each row in our input data, what we'll identify is all horizontal occurrences of the target string. That only gives us a quarter of what we need, unfortunately. But if we transpose that input data, as you can see here in this vertical section, now if we do exactly the same operations, all horizontal occurrences in this section will correspond to a vertical occurrence in the original input data. Similarly, if we rotate only 45 degrees, we get one of these diagonal patterns, and again, performing that same row by row operation, any horizontal occurrence in this section here corresponds to a diagonal occurrence in our original input data. And with that, we can build the workflow. We start off with our input data. We'll add a record ID just to index the rows. This is a very common pattern here where we use the regex tool with only a period for the regular expression, where we tokenize split to rows so that every record has exactly one character, as you can see in the results pane. Next, we will add a multi-row formula tool, or in version 24.2 and greater, we can add a record ID tool to add a column index to our data. We'll sort it, and now we're ready to orient. So in order to do that, we're going to add a new field, which we're calling the grouping field. In order to keep the horizontal structure, which is the same as our input data, all we need to do is group by the row. In order to transpose and get the vertical orientation, instead we'll group by the column. And then for both diagonals, we will group by row minus column and row plus column. For each of these, all we need to do then is group that grouping field and concatenate our data. You can see here that if we go to one of these diagonal outputs and we sort on the grouping field, we have exactly that diamond pattern that we saw originally just above. There you go. And so by unioning all of these data sources together, or these orientations together, we can now do exactly what we said before, the regex count matches function, searching for the target string Xmas or samx, since we can have it forwards or backwards, add the total number of matches together, and that gives you the number of occurrences in that specific row. Adding a summarize tool and summing up over all such matches gives us our final output to the problem for part 1. Looking at part 2, because what we're looking for is that X-shaped pattern, we can take data directly from the diagonal orientation section of our workflow. All we need to add is this multi-row formula tool where we're looking for what we've called a good A. Now what that means is we're looking for every occurrence in our data, again, in this case, on a diagonal, where an A is bounded by one S and one M. And thus you can see here that's exactly what we're doing. We're checking if the previous character, the current character, and the next character in the list are in this set. Again, because order is irrelevant. Once we identify such an A, and you can see here that we've done just that, we have good A equals 1 here because we have an S and an M which bound that A. Now, if you think about it, if we have two different sets of diagonals and we have a good A that lines up in both, if we overlay those on top of each other, what we've found is that X-shaped pattern that we are looking for. And we can do that overlay by using the join tool, joining on the row, column, and that good A field. And so anywhere in that output of the join tool where we have that match where good A equals 1, we thus have a perfect X-shaped pattern within our data. So all we need to do then is count up the number of ones here, which can just as easily be done with the summarize tool and summing up the total of the good A column to get our answer to part 2. Like I said, a very elegant solution to this problem. I appreciate the symmetry of this problem. If you agree, please like and subscribe. Comment as well if you approached this differently or had any difficulties with this problem. It took me a little bit to come up with how exactly to index these lists in order to bring them back together and obtain my final answer. But like I said, I had a fun time doing it. Share your thoughts below, and as always, I hope this helps, and happy solving.